Hello, this is Mr. Huebner with Chemistry Notes, calling this Notes at Night. It's the only time it's quiet enough at my house. What we are going to be doing in these notes are talking about physical properties, chemical properties, physical changes, and chemical changes. But before we do that, I just want to share a Father's Day gift that I got. It says, "I tell Dad jokes periodically." Perfect present. One thing that kind of bugs me though is the J-O, or is it? No, right there, yeah, J-O is element number 10, but everybody knows that element number 10 is neon, not J-O, so it kind of bugs me a little bit. Another thing that kind of bugs me about the shirt is the element J is nowhere. It's the only element that's not on the periodic table, so it's like you can't really use that. So what I'm going to do to fix it is I'm going to put with like fabric marker a 00, make it element 1000, because everyone knows that it would take 1,000 elements to discover for us to finally accept J on the periodic table. Otherwise, nobody cares about J and nobody's going to have it as an element name. But anyways, that's just me. It was a nice gesture for Father's Day, and I'm still going to wear it. But we got properties of matter. First of all, we are in our note sheet, Chem Notes 1.6 it's titled. That might change in the future. Physical properties. So physical properties are basically just kind of descriptors. You're just looking at what does it look like? What are kind of your five senses telling you about that property? Examples, as we can see in the PowerPoint, it can be observed without changing its composition. So color, texture, what does it feel like? How much does it weigh, or what's the mass of it? Is it a solid, liquid, or gas? What's the density? What does it smell like? What does it taste like? Although we don't taste things in the lab. What's the hardness, melting point, boiling point? They're all descriptors. If you can just describe it by looking at it, I mean, maybe doing some experiments that don't change its composition, those would all constitute physical properties. So if we were to write the definition, let me scooch to our sheet. Physical properties can be observed without changing its chemical properties. And that's usually just kind of like looking at it. Definitely it's not going to change its chemical properties. Physical properties. There are two types. One is intensive and the other is extensive. So let's move on. So we got intensive, we'll start with, is independent of the amount present. Independent of the amount present. Let's get that. Independent of amount present. So what that's saying is whether you got 1,000 grams or just 1 gram of the substance, that physical property is not going to change. So an example would be something like density would be independent. So we'll write down density. Because if you got 1 gram or 1,000 grams, the density of water is going to be the same. It's going to be 1 gram per milliliter. The boiling point at which water will turn into a gas will be the same. Doesn't matter how much you have. Color of water, clear. It's going to be the same no matter how much you have. So it's independent of the amount present. So we got density, boiling point, color are examples. And then we got extensive. All right, extensive physical properties. Where are we? Here we are. So extensive is dependent upon, and we're going to write this under extensive, dependent upon the amount of matter present of matter present. Alright, so example would be mass, length, and volume. So if you think about it, whether you got 1 gram or 1,000 gram, is that going to change your mass? Certainly. I mean, those are different masses. Is it going to change your length? Yes. It's going to be a smaller amount if you got 1 gram. It's going to be shorter. The volume, well, if your mass or, what was it? Yeah, if your mass is, no. If your length is changing, well, then your volume is probably going to change too. So, those are intensive versus extensive physical properties. We're going to move on to the next. All right, moving down on this. Oh, we have described the physical properties of table salt. All right, table salt looks white. That's its color. That would be intensive. It's got a specific density. I'd have to look that up for sodium chloride. That would be also intensive, independent of the amount of matter. It has a specific mass, which is extensive. Each crystal, salt crystal, can be measured at a certain length. That's extensive. It has a specific melting point, which would be intensive. And there's a lot more that we could list off. All right. So moving on. Chemical property is next. What is it? It's the substance's ability to combine with or change into one or more substance. So let's get this next definition down under chemical property. The substance's ability. Don't worry, I don't have COVID. I just have the sniffles, common cold. Let's see. Ability to combine with or change into one or more substance. All right. So this is looking at how does it interact with other substances. It's kind of looking at its social IQ. How does it mingle with the other things? So flammability would be an example. And flammability is how well it reacts with oxygen to combust and form a flame. Whether it reacts with oxygen, with like oxidation reduction, rusting. How does it react with acids or bases? Is it acidic? Is it an irritant? Those are all chemical properties. All right. Next, what we got is physical changes and chemical changes. Let's look at these physical and chemical changes. Oh, we got them right here. That's convenient. So, what are physical changes? They affect properties only, and it's basically just nothing new is formed. So let's get this down. Physical changes affect physical properties only, and nothing new is formed. So examples would be bending, cutting, split, crush, melt. And in each situation, nothing new is formed. You're just changing its form, not creating a new substance. Whereas chemical change, you get something totally new. So you get a new substance afterward. So chemical change, you get a new substance afterward. Examples would be burning of wood. You get something new? Yep. You get smoke, you get ash, you get flame. Iron rusting. You get something new? Yeah. You get a bicycle that no longer pedals because it's rusted shut. Explosion, tarnishing, you're getting something new. Rotting, good fruit, bad fruit. All examples of chemical change. Key is something totally new is formed. All right, this would be the time where you go onto the worksheet and start practicing some of those. Let me show you. We got all of those. There we go. Got those. There it is. Go on here. Let's just zoom out so you can see it better. And we got a whole bunch of different properties. We got to state, are they physical or are they chemical? And if they are physical, are they intensive or extensive? And then down here it looks like label the following: physical or chemical change. Is something new being formed? It's chemical. Nothing new is formed. It's just physical. All right, that's been this this edition of Notes at Night. Hope you enjoyed it. And here's the joke again. I tell dad jokes periodically, so I kind of like it. So have a good one, and I'll see you later.